What is temperature? Temperature is defined as the measure of heat, thermal energy, associated with the movement, kinetic energy, of the molecules of substance, or in simple word, temperature is a physical quantity expressing the degree of hotness and coldness. This definition is based on the theory that molecules of all matter are in continuous heat motion that is sensed as heat. What is temperature? Most common used unit. Celsius scale, formerly called centigrade, denoted degree C, Fahrenheit scale, denoted degree F, and Kelvin scale, denoted K. C unit, Kelvin, widely used in science and technology. What is absolute zero temperature? The temperature where all motion stop. Theoretically, the coldest a system can be is when its temperature is absolute zero, at which point the thermal motion in matter would be zero. However, an actual physical system or object can never attain a temperature of absolute zero. Temperature terminology. Boiling point. The B.P is the temperature where the vapor pressure of a liquid equals the external pressure surrounding the liquid. Flash point. The temp at which a particular organic compound gives off sufficient vapor to generate an ignitable mixture with air. Bubble point. Temp where the first bubble of vapor is formed when heating a liquid consisting of two or more component. Process. Freezing point. The temp at which liquid changed to a solid. Melting point. The temp at which a solid changed to liquid. Absolute temperature. The temp is noted in Kelvin, K, or Rankine, R. Temperature gauge and sensing element. Two type of temp. Measuring method. Contact measuring method. When the temp sensitive sensor is directly in contact with the measured medium. The non-contact measuring method involves heat radiation from the energy exchanged between measured medium and the thermometer. Types of temperature gauge. Mechanical temperature device. Respond to temperature by producing mechanical action or movement. Disadvantage: slower to react to. Electrical temperature device. Respond to temperature by producing or changing an electrical signal. Advantage: accurate and responds quickly to temperature changes. Liquid-filled system. Non-metallic liquid fills the thermal system and works on the principle of liquid expansion. 02. Fluid expansion sensors, such as mercury and alcohol-based liquid, do not require electric power, do not pose explosion nozaras, are stable even after repeated cycling. Gas-filled system. Pressure. Advantages: rugged, do not require electric power. The display can be located at a considerable distance from the measurement. Time response and accuracy are satisfactory for MOS. The Bulletin-Borden tube system generates rotational pointer movement that is proportional to the temperature. Application: wide range of applications. Temperature range, -200 to 700 degrees Celsius. Disadvantages: entire system usually must be replaced in case of failure. Large bulb is necessary for accuracy, cannot compete with the performance of electrical device. Bimetallic system. When the temperature is increased, the amplitude of the vibrations increases, and the average distance between atoms increases. This leads to an expansion of the whole body as the temperature is increased. Application: wide range of applications. Advantages: shock and vibration resistant. Thermocouple, TC. Made up of two dissimilar metals, joined together at one end, that produce a voltage, expressed in millivolts, with change in temperature. The junction of the two metals, called the sensing junction, is connected to extension wires. Any two dissimilar metals may be used to make a thermocouple. Application: wide range of applications. Temperature range, -270 tau omicron 1800 foot C. Principle of operation. If the temperature of the junction changes, it causes voltage to change too, which measured by the input circuits of an electronic controller. The output is a voltage proportional to the temperature difference between the junction and the free ends. This is called the Thomson effect. Principle of operation. Both of these effects can be combined to measure temperature. By holding one junction at a known temperature, reference junction, and measuring the voltage, the temperature at the sensing junction can be deduced. The voltage generated is directly proportional to the temperature difference. The combined effect is known as the thermojunction effect or the Seebeck effect. Disadvantages of TC. 01. The main problem with thermocouple temperature measurement is that wires A and 8 must connect to the leads of the voltmeter, which are generally made of copper. 02. If neither wire A nor wire B is itself copper, connecting to the DVM creates two more thermojunctions. Thermocouple MEDACE are typically not the SARN as those of the DVM leads. 1. 03. These additional thermojunctions also produce a thermojunctive voltage, which can create an error when trying to measure the voltage from the sensing junction. Thermocouple materials. The most important factor to be considered when selecting a pair of materials is the thermoelectric difference between the two materials. The performance of a thermocouple material is generally determined by using that material with platinum. For example, Cromwell Constantan is excellent for temperatures up to 2000 F. Nickel/nickel molybdenum sometimes replaces Cromwell alumel. Characteristic of thermocouple type. Type K. Characteristic. Color yellow material Cromwell, alloy of NiCr, alumel ally of NiAi. J. Color black material iron and Constantan, alloy of nickel and copper. T. Color blue material iron and Constantan, alloy of nickel and copper. S. Material point/RH, P1. E. Material Ni/Cr Con, N. Material Ni/Cr/CNi/C. Characteristic of thermocouple types. Variations in the alloy composition and the condition of the junction between the wires are source of error in temp. Measurement. It offers a wide temp range, low standard error, and has a good corrosion resistance. The standard error of thermocouple wire varies from plus or minus 0.8 C to plus or minus 4.4 C, depending on the type of thermocouple used. The K-type thermocouple is recommended for most general-purpose application. Choosing thermocouple type. Temperature range. Chemical resistance of the thermocouple of sheath material. Abrasion and vibration resistance. Installation requirement may need to be compatible with existing equipment. Existing holes may determine probe diameter. Thermocouple junction. 1 grounded, 2 ungrounded. 3 exposed. Thermopile. Advantage, as compared to just one sensing junction, increased sensitivity. As T2 is increased, the output voltage increases significantly. Often used to control shut-off valve in turnos. Advantage of thermopile. Small size. Convenient for mounting. Low-cost rugged wide range. Fairly accurate. Reproducibility. Good for long-term. Speedy response. No danger contaminating. Disadvantage of thermopile stray pickup a factor, susceptible to electrical noise. Calibration must match temperature. Must avoid temperature gradient. Not simul as direct reading thermometer. Thermocouple cold junction. Compensation. For a thermocouple, temperature should be measured with the cold. Meaning that we have to maintain or 529 Fa temperature smitten. Transmitter terminals, which is practically not possible. So compensation is required to correct the measured temperature reading. Thermocouple cold junction. Compensation. When a thermocouple or its extension wires are connected to the terminals of a device like a thermocouple transmitter, the cold junction is at the room temperature T1C. If both temperatures of the hot and the cold junctions are above 0 degrees Celsius, the device receives a lower EMF than when the cold junction temperature is 0 degrees Celsius. In order to measure the temperature accurately, we need to add the EMF value which corresponds to T1 to the measured EMF. To add this EMF is called cold junction compensation.